Okay, so this video is going to be on the acids and bases, and it's going to be on the buffer calculations. So to calculate the pH of an acidic buffer, which is all you'll ever be asked to do in your Unit 4 exam, is we use a rearranged version of the Ka expression. And this is our concentration of hydrogen ions equals the Ka times by the concentration of the acid divided by the concentration of the salt. So, for example, a buffer solution is made by mixing together 15 centimeters cubed of a 2.0 mole per decimeter cubed solution of ethanoic acid with Ka 1.74 times 10 to the minus 5 mole per decimeter cubed with 17 centimeters cubed of a 1.5 mole per decimeter cubed solution of sodium ethanoate. So the first thing we do is we work out the moles of the acid and the salt. So for the acid, we get the volume and the concentration, and we times these together, not forgetting to convert the volume into decimeters, and this gives us 15 times 10 to the minus 3 times by 2 to give us our moles of 0.03 moles. For the salt, we do the same steps, so we do the volume times by the concentration, again not forgetting to convert into decimeters. So we get 17 times 10 to the minus 3 times by 1.5, and this gives us 0.0255 moles. Once we've worked out our moles, then we can sub these into our rearranged K expression, so that's the one that's up here. And the reason we don't need to actually convert them into concentrations, however, is the volumes cancel, and this allows us to use just the moles. So doing this, we get our expression subbing everything in as being 1.74 times 10 to the minus 5, which is the Ka, times by 0.03, which is the acid, divided by 0.0255, the salt. And this gives us our hydrogen concentration of 2.047 times 10 to the minus 5 moles per decimeter cubed. Just pause the video, use your calculator to see if you get the same. You should. Finally then, we just calculate the pH, and hopefully you know how to do this by now. If not, look at my previous videos. And this is just minus log of the concentration of hydrogen, so that's obviously minus log 2.047 times 10 to the minus 5, and this gives us a pH of 4.69. So there you go. That is a foolproof method for calculating buffer solutions. What normally comes next from these calculations is a part 2 or a part B, and this is where we just calculate the new pH if an acid or base is added. So for example, calculate the new pH when 8 centimeters cubed of 0.2 mole per decimeter cubed solution of hydrochloric acid is added to our existing buffer solution, and that's the previous example. So make sure that you take a note of your initial moles of acid and salt, because you're going to need them for this. But the first step we do for this new calculation is we work out the moles of the acid or base which is added. So in this instance we're adding an acid, so the acid added is 8 divided by 1000, because we convert the volume into decimeters, times by 0.2, which is the concentration, and this gives us our moles added as being 0.0016, or you may have got 1.6 times 10 to the minus 3, I believe. Let me just check on that. Yeah. So next, what we do is, if acid is added, then we add the additional moles of the acid to the existing moles of acid. So let me say that again, because I feel that I didn't say that well. If acid is added, we add the additional moles of the acid to the existing moles of the acid. Also, we subtract the additional moles of acid from the existing moles of the salt. However, if base is added, as you can see, I've got two step 2s here because it's one or the other. If base is added, we add the additional moles of the base to the existing moles of the salt, and then we subtract this same additional moles of base from the existing moles of acid. This will make sense now if you look at the example. So the new acid will be the 0.03, which was the initial moles from here, and then we add on our new moles of acid, 0.0016, which is from here, and this gives us a total of 0.0316 moles. Then the new salt is the original salt, which was 0.0255 from here, and then we're subtracting the 0.0016 moles, which was the acid that was added, and that was here. And this gives us a new salt moles of 0.0239 moles. Thirdly, we sub in our new moles into the rearranged Ka expression, and again the volumes cancel, allowing us to just use moles. So if you need refreshing what the Ka expression is, again, here you go, this one here. And what that comes to then is, if you sub in all your numbers, you get 2.3 times 10 to the minus 5 moles per decimeter cubed. And the final step, calculating pH, is just the simple minus log trick. So if we sub in our hydrogen concentration to this, we will get this, and your answer should give you a pH of 4.64. And this makes sense because we've added a small amount of acid and we've become slightly more acidic. We've gone from 4.69 to 4.64. Remember, the lower the pH, the more acidic. So I hope that helped with the buffer calculations, and I just hope it made you realise that it's not as complicated as many people think.